Welcome back to my channel Statistics Made Simple, and I am Savita Valsang. In this video, I start the next topic, which is operations research, and in detail I will explain what is replacement theory and find solutions to problems based on it. Let me start with a small introduction to what is operations research. The term operations research, or OR, is related to military operations during the Second World War. Scientists use various techniques to deal with strategic and tactical problems during the war. After the war, military OR group scientists tried to apply OR techniques to civilian problems relating to business, industry, and research development. During the 1950s, educational institutions introduced OR in their curriculum. Today, service organizations such as airlines, railways, hospitals, libraries, and banks employ OR to improve their efficiency. Let us now learn one of the definitions of OR according to C.W. Churchman. Operations research is the application of scientific methods, techniques, and tools to problems involving the operation of a system so as to provide those in control of the system with optimum solution to the problem. This is an important definition. First method which I'll be explaining in operations research is replacement theory. This is an important topic from the examination point of view, and there is a sure 5 marker from here. Let's begin with an introduction. When we use equipments, machines and vehicles which deteriorate with time, it leads to decrease in their efficiency and in turn increase their maintenance costs. Take an example. With passage of time, cars, bikes, buses, trucks or any other vehicle may incur more maintenance cost. When the maintenance cost increases, it becomes necessary to replace the vehicle at some point of time. Therefore, we need to formulate a replacement policy which would enable us to decide the age at which the replacement of the old equipment by the new one is most economical rather than continuation of the old equipment at an increased maintenance cost. So replacement problems deals with replacement of machines or equipment with deteriorating efficiency over a period of time. This may be indicated in the form of increase in the cost of maintenance or repairing cost or breakdown. Let's learn a definition of a replacement theory. So, replacement theory deals with the problem of deciding the age at which an item which deteriorates with time has to be replaced by a new one. I will now explain the need for replacement. If the machine suddenly fails or is destroyed accidentally, it has to be replaced. Similarly, when the machine becomes outdated or obsolete because of technological development, newly designed machines will have to replace them. Third, when the machine wears out, its efficiency reduces, the maintenance cost of such machines is very high. Hence, it is not worth to continue with such machines. Fourth, a better or a more efficient design of the machine or equipment has become available in the market. Under these situations, the machine, equipment, or vehicles need to be replaced. I will now explain replacement of machines which deteriorate with age. For equipment which deteriorates with time, maintenance would be costlier. Thus, it would be economical to replace the equipment with a new one. The age at which the equipment should be replaced is when to date average annual cost stops decreasing and starts increasing. Let's learn how. For that, let me begin with some notations. Capital P is called as the capital cost or the purchase cost of an item. Sn, where n is a subscript, it is the resale value or scrap value of an item for the nth year. CI, it is the maintenance cost or operating cost or running cost of an item during the ith year. These notations are important, don't forget them. N is the number of years the item has been used or it is the age of the item. Then summation Ci, where I ranges from 1 to n, is the cumulative maintenance cost of the item till the nth year. Tn is the total cost incurred during the n years and is given by Tn equal to P minus Sn plus summation Ci. The average annual cost incurred on the item every year is given by the formula An is equal to Tn divided by n, which is equal to P minus Sn plus summation Ci divided by n. The last formula is an important one which is used for most of the problems under replacement theory. Also remember that P minus Sn is called as the depreciation cost. When the average annual cost is minimum, the corresponding value of n is called as the optimal replacement time. In other words, the equipment is replaced at the end of a year for which the average annual cost is the least. This concept will be understood well when I find solutions to the problems based on replacement theory in this video. Problem 1. A machine costs rupees 35,000 and the operating cost is estimated to be rupees 1,500 for the first year and increases by rupees 3,000 for the next 5 years. Determine the optimum period for replacement of the machine, assuming that the machine has no resale value. Solution, write given. So the cost of the machine, that is the purchase cost, is capital P, which is rupees 35,000. Then they have mentioned that there is no resale value, that means Sn is equal to 0. Now to find the average annual cost per year for the machine, we form a table using the formula An is equal to P minus Sn plus summation Ci divided by n. So summation Ci is the cumulative maintenance cost of the item till the nth year. In this case, it will be till the 6th year. So forming the table, in the first column we have the year, which is denoted by n. Write 1, 2, 3, 4, 5, 6, because they have mentioned that the operating cost for the first year is 1,500 and increases by rupees 3,000 for the next 5 years, means the total number of years for this problem is 6. Next column is the maintenance cost, which is denoted by Ci. So for the first year, the maintenance cost is 1,500 and they have mentioned that for the next 5 years, the operating cost increases by rupees 3,000. So for the second year, the maintenance cost will be 1,500 plus 3,000, which is 4,500. Similarly, for the third year, it is 4,500 plus 3,000 is 7,500. For the fourth year, 7,500 plus 3,000 is 10,500. For the fifth year, it is 10,500 plus 3,000, which is 13,500. And for the sixth year, it is 13,500 plus 3,000, which is equal to 16,500. Next, we need to find out P minus Sn. P is 35,000 and Sn is 0. So 35,000 minus 0 will be 35,000. So P minus Sn value for all the years from 1 to 6 will be 35,000. Next, find out summation Ci, that is the cumulative maintenance cost of the item. So how do we cumulate? The first maintenance cost is written, which is 1,500. Then 1,500 plus 4,500 is 6,000. Then 6,000 plus 7,500 is 13,500. 13,500 plus 10,500 is 24,000. 24,000 plus 13,500 is 37,500, and the last value is 37,500 plus 16,500 is 54,000. Next, let us calculate Tn, which is equal to P minus Sn plus summation Ci, which is nothing but 35,000 minus 0 plus summation Ci. All you have to do now is to add the third and fourth column values. So it is 35,000 plus 1,500 is 36,500. Similarly, 35,000 plus 6,000 is 41,000. Then you have 35,000 plus 13,500 is 46,500. Then 35,000 plus 24,000 is 59,000. 35,000 plus 37,500 is 72,500, and 35,000 plus 54,000 is 89,000. Now the calculations for the last column, that is to find out the AN values, is shown below the table on the extreme right in a pink colored box. So average annual cost for the first year is obtained by dividing the fifth column value by 1. That is 36,500 divided by 1 is 36,500. Similarly, for the second year, the average annual cost is denoted by A2, and it will be 41,000 divided by 2, which is 20,500. In a similar way, we can find out the remaining average annual costs, which are 16,166.67, 14,750, then you have 14,500 and 14,833.33. Now observe the last column values very carefully. You see that from 36,500 onwards till 14,750, the costs are decreasing. Then it decreases further to 14,500, and after this stage you see that it is increasing to 14,833.33. So 14,500 is highlighted in purple color, and this would be the minimum average annual cost, and the corresponding year is marked, that is 5. So our conclusion is that the machine should be replaced at the end of the fifth year, and the minimum average annual cost is rupees 14,500. So remember that the machine is replaced at the end of the year for which the average annual cost is the least. Problem 2. The cost of a scooter is rupees 36,000. Its resale value and maintenance cost of different years is as given below. Find when it should be replaced. In the first column, year is from 1 to 3, 4, 5, 6. Next column is the maintenance cost, that is 800, 1,300, 1,900, 2,700, 3,900 and 5,400. The resale value is 28,000, 22,000, 20,000, 18,000, 17,000 and 16,000. So these three columns are given to us in the problem. The first step is to mark the year as N, the maintenance cost as CI and resale value as SN. Let's start the problem now. Under solution, write given the cost of the scooter, which is P equal to rupees 36,000, and then you have Sn is equal to 0. So to find the average annual cost per year of the scooter, we form a table using the formula An is equal to P minus Sn plus summation Ci divided by N. So recollect that the numerator is nothing but Tn. Forming a table with 4 columns. The first column being P minus Sn. In this case, it will be 36,000 minus Sn. So The values are 36,000 minus 28,000 is 8,000. 36,000 minus 22,000 is 14,000. Do the calculations in a similar way, and the remaining values are 16,000, 18,000, 19,000, and 20,000. In our next column, let us calculate summation Ci. So the first value is 800, then 800 plus 1300 is 2100, 2100 plus 1900 is 4000, then 4000 plus 2700 is 6700, 6700 plus 3900 is 10600, and 10600 plus 5400 is 16,000. The third column, let us calculate P minus Sn plus summation Ci, which is nothing but Tn value. So all you have to do is you have to add the first column and the second column. So the first value we get is 8,800. Similarly, the next value is 16,100, 20,000, 24,700, 29,600, and 36,000. The last step is to calculate the average annual cost, which is nothing but the third column value divided by n. So the first average annual cost, that is for the first year, will be 8,800 divided by 1, which is 8,800. Similarly, for the second year, it is 16,100 divided by 2 is 8,050. Then we get 6,666.67. Then we have 6,175, 5,920, and then you have 6,000. Now observe the values in the last column. From 8,800 it decreases till 5,920, and after this it increases again to 6,000. So that means that the minimum average annual cost is rupees 5,920, and then you check the corresponding year, which is nothing but the fifth year. So our conclusion will be that the scooter should be replaced at the end of the fifth year, and the minimum average annual cost is rupees 5,920. Don't forget to write the conclusion, because the conclusion carries 1 mark and the table and the calculations carries 4 marks. Always highlight the minimum average annual cost and the corresponding year. So I have highlighted the values in purple color. Problem 3. The price of an item is rupees 900 and its maintenance cost at different years are as follows. Assuming that the resale value is negligible, find the optimum period of replacement. What is the average annual cost? So in the first column we have the year as 1, 2, 3, 4, 5. The maintenance cost values are 100, 250, 451, 651, 848. Now the first step is to mark the year as N and the maintenance cost as Ci. Let us now write under solution the values which are given. So write given the price of the item, which is P equal to rupees 900, and because the resale value is negligible, it means that Sn is equal to 0. Next, to find out the average annual cost of the item per year, we have to form a table and use the formula An is equal to P minus Sn plus summation Ci divided by n. Forming the next table, in the first column we have P minus Sn, which is 900 minus 0, which is 900. So P minus Sn values for the years 1 to 5 will be 900. Next, find out summation Ci, which is 100. Then you have 100 plus 250, which is equal to 350. 350 plus 451 is 801. 801 plus 651 is 1452. 1452 plus 848 is 2300. Then we calculate Tn, which is equal to P minus Sn plus summation Ci, which is equal to 900 minus 0 plus summation Ci. Or in other words, these values are obtained by adding the first and the second column. So 900 plus 100 is 1000. Similarly, 900 plus 350 is 1250. Then we have 1701, 2352 and 3200. Then calculate AN. So the calculations are shown below the table, highlighted in the pink colored box. So for the first year, the average annual cost will be 1000 divided by 1, which is 1000. Similarly, for the second year, the average annual cost is denoted by A2 and it will be 1250 divided by 2, which is 625. Similarly, for the third year, it will be 1701 divided by 3, which is 567. Then the next value is 2352 divided by 4, which is 588. And then we have 3200 divided by 5, which is 640. So now observing the values in the last column, we see that the values start decreasing from 1000 to 567, and after that it increases to 588 and 640. So from here we can conclude that the minimum average cost is rupees 567, and then you also check what is the corresponding year. It will be the third year. Highlight both these values. So I have highlighted the third year and the minimum average annual cost, which is rupees 567 in purple color. Now let's write the conclusion. Therefore the item should be replaced at the end of the third year and the minimum average annual cost is rupees 567. So the word at the end of a particular year is very important. Problem 4. If the depreciation cost and cumulative maintenance cost for an equipment for the third year is rupees 10,000 and rupees 10,400 respectively, find the average annual cost. So solution. Since they have mentioned the third year, it means that n is equal to 3. So under solution, we write given n equal to 3. The depreciation cost is denoted by P minus Sn. So here n is 3. So it will be P minus S3 is equal to rupees 10,000. And the cumulative maintenance cost is nothing but summation Ci, and this is rupees 10,400. So first let us write the general formula. The average annual cost per year of the equipment is AN is equal to P minus Sn plus summation Ci divided by n. Therefore, the average annual cost of the equipment for the third year is A3 is equal to P minus S3 plus summation Ci divided by 3. That will be equal to 10,000 plus 10,400 divided by 3, which is 20,400 by 3, or we get A3 is equal to rupees 6,800. Problem 5. The cumulative maintenance cost of a machine during the fourth year is rupees 13,500. If the purchase cost is rupees 8,500, find the average annual cost, assuming that the machine has no resale value. Starting with the solution, let's first write given n equal to 4. Then cumulative maintenance cost is summation Ci, which is rupees 13,500. The purchase cost is denoted by P, which is rupees 8,500, and there is no resale value. So for the fourth year, it will be denoted by S4 is equal to 0. Then write the average annual cost per year of the machine formula, which is AN is equal to P minus Sn plus summation Ci divided by n. Hence, the average annual cost of the machine for the fourth year would be denoted by A4 is equal to P minus S4 plus summation Ci divided by 4, which is equal to 8,500 minus 0 plus 13,500 divided by 4, which is equal to 22,000 divided by 4. So we get A4 is equal to rupees 5,500. The problems under replacement theory are very simple. There is only one formula and few notations to remember. So do practice these problems well. There is a sure 5 marker from replacement theory. Thank you all for watching and look out for my next video on game theory.